when a graph has exactly two vertices that has a valency which is odd, not more, exactly two odd valency, then we call that graph a semi-Eulerian graph. For a semi-Eulerian graph, we have a special restriction for making it traversable. We have to start at the vertex that has a valency of odd, and we have to end at a vertex that has a valency of odd. So we call this type of semi-Eulerian graph a semi-traversable graph. Now in this particular graph, we can see that A and H, they are the vertices that has odd number of arcs. A has one arc attached to it and H has one arc attached to it. So if we start at A, so we can travel like A, B, C, E, F, B, D, G, F, and then we can again end at the other vertex that has odd valency. We could also start from the other vertex that has a valency of odd. We can start from H. So we can do H, F, G, D, B, C, E, F, B, and end at A. So here we have another semi-Eulerian graph. So we first have to figure out which are the two odd vertices. So A has two arcs connected to it, so it's even. F has two arcs connected to it, that's also even. E has four arcs connected to it, that's also even. D has two arcs connected to it, that's also even. So we have B, three arcs connected to it, and we have C. So these are the odd vertices. So we have to start from one of these and then end at the other. So we can do B, A, F, E, B, C, E, D, and then we end at C. So here, so R has two arcs, T has three arcs, so T is the odd vertex, and then we have V has two arcs, W has two arcs, again U is the odd vertex. So we have to start from one of the odd the vertex that has the odd valency, and then we have to end at the vertex that has the odd valency. So let's start. So here we can do T, R, S, U, W, V, T, and then we can end at U. Here again it's given that this is a semi-Eulerian graph. So we first have to determine which are the vertices that has the odd number of arcs, and then we have to traverse it. So G has three arcs connected to it, so G is definitely, it has odd valency. And then we have I also has three arcs connected to it. So let's start. So if we start from G, it's going to be G, H, K, I, J, K, G, H, and then end at I. For the same semi-Eulerian graph, we can also start from G and end at I using another route. So we can do G, K, H, G, H, I, K, J, and then we end at I. Sometimes you might be asked to show that a graph is semi-Eulerian. So you have to show by drawing a table that actually exactly two of the vertices have odd valencies. So H has two arcs connected to it, so it has a valency of 2, so that's even. I has four arcs connected to it, that's also even. So J has three arcs connected to it, so 1, 2, 3, so J is odd. Then K has two arcs connected to it, L has three arcs connected to it, so L is also odd. So M has four arcs connected to it and N has 4. So this is semi-Eulerian because there are two vertices with odd valency. So the graph is semi-traversable. That means it has a restriction. We have to start at the odd vertex. So we can start at J, and then we have to end at the other odd vertex, which is L. J, K, L, M, J, I, M, N, I, H, N, and then we end it at L.